Next is 6.2 examples. This is the easiest one. X squared and root 5 plus 2x cubic are different part of the equation. We want to integrate this whole equation, but it is not possible to do it. We use u substitution. Usually the equation within the root, we can change it to u. The value within the root are easy to solve as u. I'll show you. We will set u as 5 plus 2x cubic, which is in the root. Du will be 6x squared dx. When we divide it by 6 on each side, we'll get 1 over 6 du is equal to x squared dx. When we plug in this into original equation, we'll get integral of root u 1 over 6 du. We can put the 1 over 6 in the outside of the integral, and then we can write u to the power of 1 over 2 du. When we calculate this, we'll get 1 over 6 times 2 over 3 times u to the power of 3 over 2, which is equal to 9 over 1 u to the power of 3 over 2 plus c. And when we plug the u thing into this, we will get 1 over 9, 5 plus 2x squared, 3 over 2 plus c. Don't forget to write the c, because in there didn't give us the limits. Next one. This question, we usually set the equation in the denominator as u because it is easy to cancel out the equation in the numerator when we change into u substitution. So we put u as x squared minus 4. Du will be 2x dx. So 1 over 2 du will be x dx. And plug into the original equation, we'll get 1 over 2 integral of, and don't forget, when you use u, you have to change the limits. Limits will be -4 to -3, 1 over u du. When we solve the integral, the 1 over u will be ln, and absolute value of u. And then the limits, -4 to -3. When we solve this equation, we'll get ln 3 minus ln 4. When we simplify this, we'll get ln 3 over 4. This is because the logic. And then the hardest one, this will be changing limits when we use u substitution is important. In this problem, we set u as 3 plus 3 x e to the power of x, so we have to change the limits by 3 plus e to the power of x. This one is difficult because we have to change the limits what we use in u. I'll show you. First, we have to write integral. First we have to set the u as 3 plus e to the power of x. U will be e to the power f ds. When we put it in this to original equation, we'll get 1 over u du, and then the limits will be changed because we have to plug in these numbers into the u. We'll get 4 and e plus e to the power of 2. When we solve this equation, we'll get ln absolute value of u, and then limits of 4 and 3 plus e to the power of 2. And then when we plug in u again, we'll get ln absolute value of 3 plus e to the power of x, and then limits will be changed again, 0 to 2. When we solve this, we'll get 3 ln x factorial of 3 plus e to the power x minus I to the power of 2 minus ln of 3 plus 1. And then when we solve this, we'll get ln 3 plus e to the x over 4. This is also log function. This is all that we have for 6.2.